guys, Mrs. Fishbach here. We're going to take a look at doing a dihybrid cross, which is where we will cross two traits and look at what is going to be the probability of these traits being passed on to their offspring. Using our Punnett square looks a little bit different than a monohybrid cross because we see there's going to be 16 boxes to fill out. Now, like I told you in class, there will be ways that we can take shortcuts or cheat where we don't have to fill out all of these boxes. Anytime you see a shortcut, take it, and we'll get to take a look at some of these today. Two problems that we're going to work with here. We're going to be talking about pea plants having a green dominant over yellow, or a tall plant dominant over a short plant. So these are the two traits that we are going to look at, how they are combined when we are going to cross-pollinate these plants here. If we start with a heterozygous green and heterozygous tall plant, we're going to write that genotype first. To be heterozygous green, we know hetero means different, so this will be a capital G, lowercase g for green. And this plant's also heterozygous for tall. So we will have capital T, lowercase t. We will cross this with a yellow short plant. This plant, to be yellow, which is recessive, will need two little g's. And to be short, which is also recessive, we need two little t's. Now, these are the genotypes of both of our parents. To set this up for our Punnett square, we need to figure out what are the ways that these alleles are going to combine when their gametes are forming. To do this, we will have to do FOIL. Takes a little bit of practice, but we will show how these traits are going to separate. If we start with the first parent, this big G can be passed along with the big T. So that's my first possible gamete combination, is big G, big T. This big G could also be passed along with the little t. So this is my second gamete combination. We then look at our second allele here for the green trait, and this little g can be passed along with the big T. It's my third possible combination, or the little g can go to the little t. And there's my fourth possible gamete combination. We will do the same thing to our second parent. We will FOIL their alleles. We will pair the first, outer, we have our inner, and then our last. Now, some of you guys can probably do this in your head without having to see how they pair up. When we have homozygous, recessive, or both traits, the only possible way that these alleles are going to combine is if we have a little g paired with a little t. Doesn't matter which little t it is, and this is what we're going to see for all four possible alleles. Now, I know some of you guys are already seeing the shortcuts that we're going to be able to take. If this is the same as this, we don't have to fill out all of these boxes. So here's the way that we can kind of cheat. We only need to fill out the first row of boxes to see how these alleles are going to combine. When we have the alleles set up, all we have to do is just fill in our boxes. Just like with a monohybrid cross, we will drop down and bring over our alleles to figure out what the offspring are going to look like. So if we continue to fill this out, we will get something like this. Now we can look at what the offspring will look like. We see that 1 out of 4 of them will be green and tall. We then see 1 out of 4 will be green and short. 1 out of 4 will be yellow and tall. And our last one, 25% chance of being yellow and short. And there, we have just solved our dihybrid cross, and it wasn't too difficult. For our next problem that we're going to do here, we're going to have two heterozygous parents for both traits. Now, this is the only one that we cannot take a shortcut with because there's not going to be any repetitive combination of alleles. Everyone's going to be different. We'll still set this up the same way. We will FOIL to get our allele combinations, big G to big T, or big G to little t. We can see little g little t, or big T, and then little g little t. We'll do the same thing over here, and we'll write these parents' alleles going down the side. Now, I know some of you guys asked in class, does it matter which parent goes across the top versus down the side? No. It doesn't matter. When we combine them, the offspring are still going to have the same results. So let's FOIL the second parent here. Big G, big T, big G, little t. Little g, big T, little g, little t. That was the hard part. Once we have FOILed our parents to get the combination of alleles that they could pass on, all we have to do is fill in our Punnett square. Now, there is no shortcuts because none of these are going to be the exact same thing, so we're going to have to fill every box out. And this will take a little bit of time. I timed myself in class today, 4th hour, and it took me 37 seconds to fill this out. We'll see if I can get any faster. That should be a little t, so that means this one's a little t, these two are little t's, little t. Okay, got the problem. Alright, our last step, we're just going to take a look at what the offspring are going to be. If we want to see how many are going to be green and tall versus green and short, yellow and tall, yellow and short. Okay, I'm just going to go ahead and circle out all my green and tall. So this is green and tall, green and tall, green and tall, green and tall. We then see we have green and tall, we have green and short, nope, then we have green and tall, green and short. So we have green and tall, yellow tall, yellow tall. We have green and tall, we have green and short, we have short and yellow. Okay, so this looks like we got everything right. If we count how many we have, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 16 are going to be dominant, dominant. And then I'm going to look for my green and short. I'm going to use a different color here so this will stand out. So we have green and short, and then we have green and short. I will have 3 out of my 16 are going to be green and short. Changing colors again, I'm going to find yellow and tall, and that's going to leave me with these 3 right here, 3 out of 16. And then my last one that I haven't circled, I'm going to have 1 out of 16 is going to be yellow and short. Now, while there's no shortcuts to take filling out the Punnett square, if on a quiz I ask you how many can you predict to be yellow and short if both parents are heterozygous for each trait, we know that it's always going to be in this ratio of a 9 to 3 to 3 to 1 for our dominant, 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 recessive, recessive, dominant, recessive, recessive. So if we're asking recessive, recessive, we know, without even filling this out, there's only a 1 in 16 chance that this is going to happen. If you guys still have questions on this, come see me and we can work out some problems together.